Hello Professor, my name is Sukhat and in this video I'm going to do the walkthrough for my assignment 2 where I build a network monitor in Linux. The project combines system programming, networking concept, process control and socket communication, and I will explain how the entire design works, why it's useful, and how I implemented and tested it. Before we dive into the code, let's try to understand the business use case that we are building. Let me pull my assignment file. Alright. So modern routers and servers can have a lot of network interfaces, sometimes 32, 48 or even 64 interfaces, and many of them run at a speed like 10 gigabit per second. To keep everything running smoothly, we need a tool that constantly monitors the health and performance of these interfaces. A central network monitors helps us that detects the problem faster, automatically bring interface back up, collect statistics in real time, and improve reliability of the system. In this assignment, we replicate this idea. So we build a central controller called network monitor. And for every network interface we run a separate child process called the interface monitor. This architecture is similar to how software defined networking centralized logic works. For the requirement of our assignments, our network monitor must perform several tasks. That's the user, I think it's a bit down. So it should query the user for the number of interfaces they want to track, and program monitors them. And when they enter those, it reads the stats and include up count, down count, RxTX status, drop packet, and bind with the socket. And it should detect if an interface goes down. If the interface goes down, it should display those in the status. So while also shutting down, if the user press Ctrl C, it should quit everything. The user can type so quit, which instantly so the current stats are quit, gracefully shut down. Gracefully intercept, should not die. It should close the socket, stop interface monitor, delete the socket files, exit entirely. This ensured there is no leftover TMP, zombie process or socket files. So this entire system has two major components. Let me go in my code base now. There is interface monitor and network monitor. Interface monitor is our child process. So interface monitors creates a unique socket. Let's open my interface monitor. Okay. So it connects to the master network. It sends ready to signal and waits for a signal monitor. And if the interface goes down, it links down. If told to bring up, it uses an IOCDL call. On shutdown, it sends done and exit. And there is another network monitor, which is the parent process. Network monitor.c. So what this guy does is it asks the user for how many interfaces they want to monitor. It creates the master socket in TMP using the username from get-env-users. It calls fork and execute for each interface. It uses select to listen on the master socket, all interface sockets, standard output input for commands. When an interface monitor sends ready, it replies monitor. If it reports link down, it sends set link up. Intercept Ctrl C to begin control shutdown. This setup allows the network monitor to control multiple processes at the same time. Now, what are the IOCDL commands? IOCDL stands for input output control. These commands let program control hardware level behavior. In our project, we use IOCDL to bring a network interface up, restore a link when it goes down. IOCDL cannot source it, but we are using IOCDL commands. Okay, let's run the application. I'm just gonna, so we have three files: network monitor, interface monitor, and makefile. Makefile is pretty much for the compilation. Make clean. I'm just gonna clean my old makefile. There are some warnings. I did try to solve it, but I was not able to solve it. It does not creating an issue for our program, so I'm ignoring it for now. So there should be an executable. So I'm just gonna run the network monitor as super user sudo network monitor. All right, hope it works. Okay, it works. So before doing this, let's print all our interface that's available. If config, yeah, there are two interfaces. So let's run our application. Let's do two interface. Just gonna go this one, another interface, this one. So it's just gonna run and it's keep listening every seconds. So when I do show, it should quickly show. When I do quit, it should gracefully quit. And then test link down detection. Okay, so I'm just gonna set my LO down. Let's run it. What happens? So before state unknown. Okay, it's unknown right now. Let's run it. THOLO. So state down, as you can see, the state is being changed. So even if I just do dynamically, it will do up if I do whatever up those. Control C is shut down. No zombies, no TMP left. All right. So this assignment, in conclusion, this assignment gave me hands-on experience on working with Unix daemon sockets, fork and execute process creation, select from multiplexing I/O, Linux virtual file system, handling SIGINT and lifecycle management. Real-world networking concept is the assignments being displayed and provided. It helped me to think like a system programmer and understand how professional networking equipment is managed in real-time environment. Thank you so much.